All right, so we're going to graph y is equal to the sine of x. All right, the most basic sine function. So the first thing we're going to do is we're going to find the period. Right, so the period formula is 2 pi over b. So recall that b is the coefficient of your x variable. So notice that we have y is equal to the sine of x, and the understood coefficient of x is positive 1, right? So we're going to substitute b for 1, right? So our period is equal to 2 pi over 1, which is 2 pi, right? So it's going to take 2 pi radians, or 360 degrees, for the sine to complete one rotation or one revolution. The next thing we're going to do is we're going to quarter the period. All right, we're going to break it up into 4 equal parts. What we're doing when we quarter the period is we're basically taking the unit circle and we're laying it out on a straight line. All right, so how do we quarter the period? Well, we're going to take the period, which is 2 pi, and then we're going to multiply 2 pi times 0 over 4. We're going to multiply 2 pi times 1/4. We're going to multiply 2 pi times 2/4, right? And technically 2/4 is 1/2, right? But this is just to show how we are quartering the period. We're going to multiply 2 pi times 3/4. And then lastly, we're going to multiply 2 pi times 4/4, right? Which is technically 1. And now we're going to reduce. All right, so 2 pi times 0 is 0. 2 pi times 1/4 is pi over 2. 2 pi times 1/2, right, or 2 pi times 2/4, we should get pi. 2 pi times 3 pi over 4, we get 3 pi over 2. And then lastly, 2 pi times 1 is 2 pi. Right, so here we have the values when the period is quartered. Okay, so notice we're multiplying by 0/4 through 4/4. Now we're gonna graph. Now when we graph, and this kind of goes back to algebra, you can graph basically any function by using an x and a y chart. So we're going to use an x and a y chart to graph. Right? So you may say, well, what are the x values? So we're going to create an x and y chart. Okay, so you may say, well, what are the x values and what are the y values? All right, well, the x values are the values that we found on the previous step. Right, the x values are 0, pi over 2, pi, 3 pi over 2, and 2 pi. And when we graph, they also serve as the points for our x-axis. Right, so if I were to make a rough sketch over here, we have 0, pi over 2, pi, 3 pi over 2, and 1 complete revolution at 2 pi. Okay, so notice that they serve as our x coordinates. So now, what are the y coordinates? Well, keep in mind that these things are nothing more than ordered pairs. Right? So how do we complete the first ordered pair? Well, we're going to set y equal to our function. Y is equal to the sine of x. So we found our x values, right, by quartering the period. We're going to let y equal to the sine of x. So in order to find the y coordinates, we'll simply evaluate the x value with the sine. Right? So here's how that works. So if we look at our first ordered pair or our first data point when x is 0, in order to find the y coordinate, I'm going to substitute x with 0. So if we were to find the sine of 0 degrees, I can pull up the unit circle. I can pull up the unit circle. I can find 0 radians because we're working in radians. In order to find the sine, I would look at the y coordinate. So the sine of 0 radians is 0. Right? So that's my first ordered pair, 0, comma 0. Next, we can find the sine of pi over 2. So if I pull up my unit circle, notice I have pi over 2, which is 90 degrees. If we're trying to find the sine would be the y coordinate, which is positive 1. So the sine of pi over 2 is equal to 1. Right, so that gives us an ordered pair point. The sine of pi, right, so again, looking at the unit circle, pi is 180 degrees, so the sine of pi is 0. The sine of 3 pi over 2 is negative 1. And then 1 complete revolution, the sine of 2 pi is 0. Right, so we have our x and y chart. Right, so now we're going to graph. So notice that my x-axis is laid out as 0, pi over 2, pi, 3 pi over 2, and 2 pi. Notice for the y values, they range between positive 1 and negative 1. All right, so now we're going to plot. So my first ordered pair is 0, comma 0, so that's at the origin. My next ordered pair point is pi over 2, comma 1. So I'm at the origin. I'm going to go over pi over 2 units to the right, and I'm going to go up 1. Next, we have pi, comma 0. So I'm going to plot the point pi, comma 0. Next, we have 3 pi over 2, comma negative 1. And then we have pi over 2, comma 0. Oops. And now if we connect, now what says is additional cycles is needed. This thing is periodic and it'll keep its same pattern. It'll keep its same pattern. All right. So before I actually pull the calculator up, I want to talk about a couple of concepts. We talked about the period, right? The period is the time it takes for your curve to make one complete cycle. So notice that the period here is 2 pi. There's also the amplitude. The amplitude, I'm going to pull up the definition for the amplitude. The amplitude okay, I think all of my stuff closed down. I'm going to bring back up the lecture notes for a second. Right, here is the amplitude. And it says that the amplitude of a periodic function is half the difference between the maximum value and the minimum value. The amplitude is the absolute value of A, right? So this very last line, it says that the amplitude is the absolute value of A. So what is A for our graph? I'm going to go back to OneNote real quick. All right, so the amplitude is the absolute value of A. So notice that for our setup, y is equal to A. Right, so notice that A is understood 1, right? A times the sine of bx. So the amplitude is the absolute value of the coefficient of your sine term, which is 1. So the amplitude is actually 1. Right, so the amplitude for our function is 1. So notice it says this is half of the maximum height and the minimum height. So if we look here, the maximum height is at positive 1. The minimum height is at negative 1. So that would actually give us a total distance of 2, right? So if we were to count, we would count 1, and then we'll count 2. Half of that gives us 1, right? So the amplitude here is 1, and the amplitude is always positive. So now we will graph using the calculator. All right, so just a couple of things using the calculator. When you graph trig functions on a calculator, you want to make sure, unless it's stated otherwise in the problem, that your calculator is in radian mode. And the reason why we want it in radian mode is because just taking a look at our handheld sketch, notice that our x-axis, it does not go in the interval of 1, 2, 3, 4, 5, right? It's measured in radian measure. So you want to make sure that your calculator is in radian mode unless it states otherwise in your problem. So I have the correct mode. So I'm going to go back to the home screen. I'm going to go into y equals, and I'm going to put in the sine of x. And I want to make sure to close off the argument of my trig function. So now I'm going to hit zoom and 6. So let me explain what zoom 6 does. Zoom 6, it puts your calculator as having an x minimum of -10 and x max of +10 with increments of 1. right? So I could actually count 1, 2, 3, 4, 5, all the way to 10. That's both for the X and the Y axis. Next, I'm going to hit zoom, and I'm going to hit zoom trig, Z trig. And what this does to our calculator is that it resituates our x-axis. So the x-axis is no longer 1, 2, 3, 4, 5. The x-axis is now 0, pi over 2, pi, 3 pi over 2, and 2 pi. Okay, it's actually following radian measure. So notice as we graph the first or one of the periods from 0 to 2 pi, right, notice we have the same exact graph on our calculator. All right, so next we're going to just look at this sine function capsule. So I'm going to just zoom out a little bit. All right, so this is just the graph of a sine function. It says from the graph we can see that as s increases, sine of s oscillates between +1 and -1. All right, so oscillates means that our graph is actually in between +1 and -1. All right, it's kind of oscillating or going in between those two values. The graph is continuous on the interval from -infinity to +infinity. So the definition of continuous means that you can place your pencil on the graph and you can trace the entire graph without removing your pencil from the paper. All right, so this graph is continuous. The x-intercept, so keep in mind an x-intercept is where your graph crosses or touches the x-axis. They're given by this form, n times pi, where n is an integer. So keep in mind that integers are positive and negative whole numbers. So let's just say if we take the integer 0, 0 times pi is 0, and notice that when x is 0, we have an intercept point. Next, you can substitute n for +1. So 1 times pi is pi. So notice that at pi, we have an x-intercept point. So this gives us the form for all of our x-intercepts. We can find the period, right? The period is 2 pi. And the graph of sine is called an odd function. Now, from algebra, odd functions are symmetric with respect to the origin. To be symmetric with respect to the origin means that you're both symmetric with respect to the x-axis and the y-axis. Right? So sine is an odd function. All right, next we're going to take a look at the cosine curve. All right, so we're going to graph y is equal to cosine x. All right, so here again, we're going to follow those 5 steps. The first thing we're going to do is find a period. All right, so the period has a formula of 2 pi over b. We can pull b from our equation, which is the coefficient of x, and it's understood 1. So the period is 2 pi. Next thing we do is we quarter the period. Right. So since our period is 2 pi, right, the same as in the previous example, here are the values for x we're going to use. 0, pi over 2, pi, 3 pi over 2, and 2 pi. you're going to notice that once you quarter your period, you should always, and I mean always, return to these values. So when we quarter the period, we have 0, pi over 2, pi, 3 pi over 2, and 2 pi. Next, we're going to make an X and Y chart. So the values for X are those previous values. So we have 0, pi over 2, pi, 3 pi over 2, and 2 pi. The Y values are equal to cosine X. Okay. So for our first ordered pair, we're simply going to substitute cosine X. We're going to substitute X for 0. And if we look at the unit circle, in order to find the cosine of 0, we can locate 0 radians. The cosine corresponds to the x coordinate, so the cosine of 0 is positive 1. So that's our first ordered pair, 0, 1. Next, we can find the cosine of pi over 2. Right, so if we find pi over 2, cosine is the x coordinate, so we have 0. The cosine of pi, right, is negative 1. The cosine of 3 pi over 2. So if we find 3 pi over 2, cosine is 0. And we complete one complete rotation back at positive 1. All right, and now we're going to sketch. All right, so on our x-axis, we have 0, pi over 2, pi, 3 pi over 2, and 2 pi. On our y-axis, we're going to list out 1 and negative 1. Okay, and we're going to plot. So we're going to plot 0, comma, positive 1, which is here. Pi over 2, comma, 0, which is here. Pi, comma, negative 1, which is here. 3 pi over 2 is 0. And we have 2 pi as 1. All right, so that's the graph of cosine x. All right, now in order to graph that on a calculator, I'm going to go into y equals, and you want to make sure that we are in radian mode. All right, I'm going to hit cosine x. I'm going to graph. And notice we have our cosine curve. All right, so if we go to the function capsule for cosine, it says the graph of cosine x can be found much the same as sine x. Notice that the graph of cosine x is the graph of sine x translated or shifted pi over 2 or 90 degrees to the left. So if you were to take the sine curve and slide it 90 degrees to the left, you would in fact have the cosine curve. So here are some additional facts. Okay, the graph is continuous. The x-intercepts are in this form, 2n plus 1 times the quantity pi over 2. Right, so using that form, you can find all of the x-intercepts. All right, so at this time, I'm actually going to give you a problem to attempt to graph. Let's see. All right, so I would like for you to graph y is equal to 3 times the sine of 1/3 x. All right, so and we're going to do a hand sketch. We'll also check it with the calculator, but we're going to do a hand sketch. So I'm going to give you a 5 minutes or so to try to graph, and then we're going to return with the solution. All right, we're going to return with the solution. So the first thing we're going to do is we're going to find the period. All right, so the period has the formula 2 pi over b. In this case, b is 1/3, right? That's the coefficient of x. So we have 2 pi divided by 1/3, which is actually 6 pi. Now, one thing I'm gonna bring up a formula from algebra, and it says that a over b all over c over d. It says that you can multiply the very top and the very bottom, right? So I can multiply a times d. I can multiply the very top and the very bottom, and that would go in my numerator. And then I can multiply the bottom of the top and the top of the bottom, and that goes in the denominator. Right, so as I look at this, I can actually write 2 pi, which is in the numerator. I can express that as a fraction as 2 pi divided by 1, right? All divided by 1/3. So then I can multiply the very top and the very bottom. So 2 pi times 3 is 6 pi. I can multiply the bottom of the top and the top of the bottom, just so this looks consistent. I can multiply the bottom of the top and the top of the bottom. 1 times 1 is 1. So 6 pi over 1 is 6 pi, right? So it's going to take this function 6 pi radians to complete 1 revolution, 1 complete rotation, or 1 cycle. Right, so 6 pi is the period. So next, we're going to quarter the period. So we have 6 pi times 0/4, 6 pi times 1/4, 6 pi times 1/2, 6 pi times 3/4, and 6 pi times 1. Right, so once we simplify, I believe we should have 0, 3 pi over 2, 3 pi, 9 pi over 2, and 6 pi. Now, one thing I have observed is that when you graph by hand, the hand graph is going to be a little bit different than the actual what you actually place in the computer. Okay, so the graph may not be laid out, the x-axis may not be laid out as such. Okay, I'm kind of looking at the homework and they're using like 0, 3 pi, 6 pi. They're not actually using 3 pi over 2 and 9 pi over 2 on the x-axis, right? But they're still there. All right, so we've quartered the period. The next thing we're going to do is create an X and Y chart. So we have X, and those are the values that we have previously found. We have 0, 3 pi over 2, 3 pi, 9 pi over 2, and 1 complete revolution at 6 pi. Now our y values are going to equal to 3 times the sine of 1/3 x. All right. So I'm actually going to complete that over here. So we have y is equal to 3 times the sine of 1/3 x. We're going to first substitute x for 0. So we have y is equal to the sine of 1/3 times 0. So 1/3 times 0 is 0. Right. So now when you evaluate the trig functions, okay, the first thing I did was I simplified, 1/3 times 0 to get 0. Now I'm going to evaluate the sine of 0. Right, so keep in mind from our unit circle, right, I can find 0 radians. The sine represents or corresponds to the y coordinate. So the sine of 0 is 0. Right, so I've evaluated the sine of 0 as 0, and 3 times 0 is 0. Right, so our first ordered pair point is 0, comma 0. All right, next we're going to complete the next ordered pair. Right, we're going to substitute x for 3 pi over 2. So y is equal to 3 times the sine of 1/3 x. X is equal to 3 pi over 2. Right, so I'm going to substitute x for 3 pi over 2. So that's 1/3 times 3 pi over 2. So notice that the 3's will cancel. Right, so I'm left with pi over 2. Right, so notice how it kind of reduces down to the values that are in the unit circle. So if we were to use the unit circle, right, we would have the sine of pi over 2. Okay, I'm still here. Right, the sine of pi over 2 is 1. All right, so that's 3 times the sine of pi over 2 is 1. So we have our next ordered pair point as 3 pi over 2, comma 3. Next, we're going to substitute x for 3 pi. So y is equal to 3 times the sine of 1/3 x. We're going to substitute x for 3 pi. So we have 3 times the sine of 1/3 times x, which we're going to substitute for 3 pi. Notice that the 3's cancel. We have 3 times the sine of pi. And from the unit circle, the sine of pi is 0. So we have 3 times 0, which is 3. next we're going to substitute in 9 pi over 2. Excuse me, that's 0. I'm sorry. It should be 0. All right, next we're going to substitute in 9 pi over 2. So y is equal to 3 times the sine of 1/3 x, but we're going to substitute x for 9 pi over 2. So this is 3 times the sine of 1/3 times 9 pi over 2. Right, so we can cross cancel the 9 and the 3. So we have 3 times the sine of 3 pi over 2. So if you use your unit circle, the sine of 3 pi over 2 is -1. And 3 times -1 is -3. Right, so we have the ordered pair point 9 pi over 2 comma -3. And then lastly, we're going to substitute in 6 pi. So y is equal to 3 times the sine of 1/3 x. We're going to substitute x for 6 pi. So this is 3 times the sine of 1/3 times 6 pi. Right, so the 6 and the 3 cancel. We have 3 times the sine of 2 pi. Right, and the sine of 2 pi is 0. So 3 times 0 is 0. All right, and lastly, we're going to graph. All right, so I'm going to draw the graph here, and I'm just going to draw one graph, one cycle. All right, so notice on our x-axis, we should have 0, 3 pi over 2, 3 pi, 9 pi over 2, and 6 pi. And if we look at our y values, they range from +3 to -3. So here is +3, here is -3. All right, so we have 0, 0. We have 3 pi over 2, 3. We have 3 pi, 0. We have 9 pi over 2, -3. And then one complete rotation at 6 pi, 0. Oops. All right, and this is right, and this is our graph. Okay. All right, next we're going to talk about amplitude period. We're going to talk about phase shift, and we're also going to talk about vertical translations. And I'm going to go back to algebra for a second, and I'm going to talk about some translations. All right, and it seems that our time is running down. It's 12:35, 12:31. All right, so I think what I'm going to do is I'll end class here, and when we pick up on next time, we'll talk about phase shifts, and we'll talk about vertical translations, and I'll kind of talk some more about the amplitude and the period. I wasn't quite, I didn't know time ran out. I had a statistics course, and time sort of ran over, and that was one of the reasons I got started kind of late here today. But we'll just see how it goes in the future. At this time, I'm going to stop the recording.